Hi, what's the crack, physicist? So what we're doing today is that we're going to look at simple harmonic motion again to figure out what is the time for this particle to travel from maximum displacement to its mean position. And it's one of these options. Okay. So what we do first is I would look at my data sheet for simple harmonic motion and again see x equals a cosine of wt. So again, that's for something that starts at a maximum amplitude of positive a. So I look at my equation I have, and I want to compare them. So I have s equals 5 sine of 20 pi times t. Okay, so my s is trying to show me the displacement. That's the x. Okay, I can see its maximum amplitude is 5, but what I care about is the time. So how long does it take? Okay, so what I look at then is I can see my W here is 20 pi. So I'm going to write that down. The W is 20 pi. Okay, I look at my data sheet to see what W stands for. So W is my velocity in circular motion. Okay, my speed in moving through a circle. So it's 20 times pi, and on the equation sheet that tells you it's 2 pi f. 2 pi times the frequency. I know from GCSE that frequency equals 1 over time. So I can change this equation to get the time, because that's the whole thing I care about, how long. So I can change this now to write W equals 2 pi over time. Okay, so I just make frequency is 1 over time. So now I compare my two equations. So I have W equals 20 pi from the initial equation, which must be equal to 2 pi over t. So I'm going to write that down. So I have 20 pi equals 2 pi over t. And the whole point is that I'm trying to find t. So what I do then is I can multiply both sides by t to get 20 pi times by t is 2 pi. I can divide both sides by pi to get rid of it and divide both sides by 20 so that I have t is 2 divided by 20, which is 0.1 seconds, okay, or 1 over 10. Okay, so a lot of people want to pick this answer first. But if we read the question, it doesn't say how long in time for a full oscillation. It says how long in time does it take the particle to travel from its position of maximum displacement to its mean. Okay, so if I drew that as a picture, let's say we model it as a spring, there is my mean. That's my equilibrium. So let's say I stretched it down through my amplitude of 5. So we moved it down by 5, and it starts here. The time that I calculated was the time for this spring to go the whole way back up to its maximum amplitude and the whole way back down to its minimum amplitude. Okay, so that's the time I calculated. But the time that I want is from maximum displacement to the mean. So I only want this time. And if I look at it, that time is a quarter of the whole time. So my time is a quarter of the whole time. So the time that I want is a quarter times the time for the whole motion that I found out over here. So a quarter times 1 over 10, which gives me a final answer of 1 over 40. So that's why it has to be A, 1 over 40 seconds.